Okay, I wanted to show you an example of a free fall problem that looks a little more complicated, but it turns out it's not. So let's just take a look at this. We've got a projectile that's launched vertically, that means straight up, with a velocity of 100 meters per second. Now it's going to pass the 30-meter mark twice, 30 meters above the ground, once on the way up, and then eventually that thing's going to stop and come back down, and it's going to cross that 30-meter mark again. So on the way up and once on the way back down. And what we want to determine is what are the two times at which it crosses that 30-meter mark. Well, okay, so you know the first thing I'm going to do is draw a picture. I'm going to move a little faster than normal since I think you're getting used to the process. My picture looks something like this. You know, I've got my ground, show my projectile being launched at 100 meters per second. I've put in my coordinate system, zero's down here at the bottom. I've made a 30-meter mark. And so this guy starts down here. On the way up, he's going to cross the 30-meter mark, going up, and then on the way down, he's going to cross the 30-meter mark. And what we want to know is, what time is he going to get here? We're going to call that T1. And what time does he get here? We'll call that T2. Okay, so that's a picture that helps me kind of get oriented to where I'm headed. Now let's write out our knowns, and I'm just going to put the list here. Here's what I know. I know that my initial time is 0 seconds. The problem didn't give me a time to work with, so I'm going to say we started our watches right at the moment that it was launched, so 0 seconds. My initial position is going to be 0 because I'm down here on the ground. Now my Y final. Remember, Y final is just the later points at which you want to determine something about what's going on at that position. So my Y final is going to be 30 meters on the way up and on the way down, okay? And my acceleration, always put that in. It's not stated, but this is a free fall problem, right? And right now we're ignoring air resistance. So the acceleration's a negative 9.8 meters per second squared. And that's pretty much what we know, okay? Now what do we want to find? Well, we want to get T1, the time it crosses 30-meter mark going up. And we want to get T2, the time it crosses the 30-meter mark coming down. Okay, so there's my knowns. I've defined what I'm looking for. Now remember, picture, knowns, what you want to find, go to your toolbox. Well, this is accelerated motion. And so you know that we've got these three basic equations that are going to work for us, possibly, with an accelerated motion problem. Okay, so I'm going to look at my equations now, and I'm going to go, based on the information I have, what equation can help me the easiest? Well, if you look at this, two of these equations are eliminated immediately because they would require us to know something more. And that is this equation because it's got a final velocity, and this equation because it's got a final velocity. We don't know those things, okay? This one wouldn't have been useful anyway. It doesn't even have delta t in it, okay? But this guy, we would need to know Vy sub f, wouldn't we? We could probably figure that out. And that's the thing. I do want you to understand. I don't want you to think that there's always just one equation that's going to give you the answer. Sometimes you're going to have to use one equation to solve for a number that you can put into another equation to get the answer you're looking for. Be watching for that, okay? But I look at this one and I go, hey, I know Y final, I know Y initial, I know Vy initial, and I know my acceleration, and I'm looking for delta t. So this is the equation that I'm going to start working with immediately, okay? So let's put this equation down here, and we've got it laid out, and what you do next is you go back up to your list of knowns, and you substitute in for everything that you see. So that's what I've done here. I've got 30. I put in 0 for my Y initial. My Y final is 30. My Vyi is 100, and my acceleration is negative 9.8 delta t squared, okay? Now, let me multiply this out so you can see it. I've got this. Now, this equation is tricky because you can already see that this is a second order equation. We've got a t squared here, right? And so I'm going to have to rearrange all this stuff, and I'm going to pull it all to one side, okay? What I have is basically a parabolic equation here, right? And I'm going to have to solve for delta t. The problem is, to solve this, the way this is set up, I'm going to have to use the quadratic equation. Yeah, that's right. There's some of that stuff that maybe you haven't used in a while that you're going to have to pull out and put in your toolbox, right? So I've got this equation right here. I'm going to have to use the quadratic equation to solve it. Remember that quadratic equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I wasn't going to have to type that equation in twice. You can write it down before you move on in the video if you want to. But when I write that quadratic equation with everything substituted in, here's what I get. My delta t is going to be negative of negative 100 because that's negative b, right? My b is a negative 100. So negative of negative 100 plus or minus, here's my square root, there's my b squared, right? Minus 4 times a. A is what's in front of the squared factor, right? So that's 4.9. And multiplied by 30, that's c, 4ac. And of course, I've got to divide the whole thing by 2 times a. And again, a is 4.9, right? Okay, so that's my delta t. And when I solve that, I'm going to get two values, right? Because I have a plus and a minus here. And so I get two values, 0.305 seconds and 20.1 seconds. But guess what? I need two values. I expect two values because I'm crossing that point twice at two different times. So here's what we've got. When we solve this, the 0.305 seconds, that's how long, that's the time at which it gets to the 30-meter mark. The 20.1 seconds, that's when it's gone all the way up through its motion and come back down and reach the 30-meter mark again. So the 20.1 seconds is our T2. So this is T1, what we were looking for, and this is T2, okay? So it's really cool. You know, you may have been wondering, well, don't I have to do two different problems to get two different times? Well, no, this equation right here encompasses the entire motion of the object up or down, all right? It's just sometimes you've got to be ready to make a decision. So say, for example, I had asked this problem and I just said, well, I want to know what time it's going to pass the 30-meter mark on the way down. I'm not really concerned about T1. I want to know T2. And so you're going to do this, and you're going to get this equation and solve for it. And then you're going to get two answers, and you're going to have to make a decision. You're going to have to think about the physics. Which one most naturally is going to correspond to motion back down? Well, it's not the earlier time. It's the later time. Okay? So this is just a basic problem. I wanted to show you another free fall problem. Hope it helps. If you have any questions, just let me know.